Hi everyone. So yesterday we had a DSA contest and let's discuss its solutions. So the first question was Ravi and magical coronavirus. So it was made by Milan, and the question says that we have n troops of virus, and when we kill a troop with a bottle of hand sanitizer, what happens is it halves. Let's say if the size of the troop is X, the size of the remaining troop will be x by 2, and the troop with x by 2 will again join, and a troop with size x will be removed. So what happens in the question is that let's say if we take the sample, we have three bottles, and we have troops of size 2, 3, 8, 4, and 2. So what happens is if we use the first bottle on the third troop, that is of the size 8, the troop with the size 8 will go away, and another troop with size 8 by 2, which is 4, will be inserted, which means we have 2, 3, 4, 4, 2 now. So as you can see, what happens is we have a limited number of uh, hand sanitizer bottles. So we should try to optimize the use of hand sanitizers. So what happens is at every iteration, if we pick the bottle, if we pick the troop with the maximum number of virus in it, what will happen is if we choose this way, which is called a greedy approach, we can kill the maximum number of viruses. So what happens is uh, by doing so, we can kill maximum number of viruses, which is the optimal solution. So to solve this question optimally, what we need to do is we need to find the maximum number of uh, we need to find the troop with the maximum number of viruses at each iteration, and then we need to remove it and insert. If the size is x, then we need to insert x by 2 every time, and yeah, that will be the solution. So in order to solve it, the brute force solution would be for each iteration, for each of, so we have k hand sanitizers, right? So we'll have to run a loop for k times, and for each of the k iterations, what we can do is we can iterate on the array of this uh, coronavirus troops, and we can find the maximum, and then we just add it to our answer, and then we half the value. So let's say if the maximum is x, we do x divide equal to 2 in the array. So what happens is we what we have is so what happens is for each of the k iterations, uh, so we need to do k iterations for the k bottles, and in each of the iteration we will have to iterate through the array to find the maximum, which will mean we will have to do o of n work per k iteration, which is o of nk in total, which is too slow to pass the given test case, because o of nk will be 10 to the power 5 into 10 to the power 5, which is 10 to the power 10. But as we discussed in the one of the tips and tricks videos, typically we can do 10 to the power 8 operations in 1 second on HackerRank. So what happens is 10 to the power 10 operations aren't gonna pass. But if you try to do that solution, you might get some partial score. But to get the optimal score, you need to do it optimally. So the optimal solution is so basically this was a HTL question, and what you really need to do is you need to use priority queue, and if using priority queue, you can find the maximum element in the array in O of log n time. So priority queue allows for insertion, deletion, and get max in O of log n. And using that, what happens is for we run a loop for k times, and we insert all the array elements into the priority queue. We get the maximum element from the priority queue, and we take it, we add it to the answer, and remove it from the queue and insert x by 2. If x was the maximum, we insert x by 2 into the queue, and that makes for the optimal solution. So what happens is for each of the k iterations, what we are doing is getting max, which is O of log n, where n is the number of elements in the array. I yeah, n in the question. So we have each iteration doing a get max operation, which is O of log n, and again inserting, which is O of log n. So if you dig into the internals, you will find that The priority queue in C++, HTL, or Java are implemented using some kind of tree data structures, which allows them for big O of log n insertions and deletions. For C++, I'm not very sure, but I think it's some kind of heap implementation. And using that, what you can do is you can solve this question in complexity O of k times log n, because each iteration is one insertion and one deletion from the priority queue, which makes it log n. So solution becomes big O of k times log n, which is fast enough to pass the test cases. And we'll share the optimal solutions using a link. Now let's go to the second question. So I think in this first question, the only catch was that you had to recognize that it was an HTL question, and you had to use the optimal way to find maximum in the array. And if you did not know how to use a priority queue, or like priority queue is the optimal way to find this, then yeah, I think that was where many of you were stuck. You were trying to do a maximum in O of n rather than O of log n, and that was why your solution were not passing. And yeah, another small catch that this question had was size of troop was up to 10 to the power 10. So I think some of you may have recognized it, some of you did not, that if the size of the troop is up to 10 to the power 10, that means it cannot fit into int, which is the 32-bit data type in C++ and Java. So if you're using C++ or Java, what you had to do is you had to use long in C++ or long in Java, which are 64-bit, and therefore they allow values up to 10 to the power 18. So now let's move on to the second question. So let's once again, let me discuss what was, can we use heap as priority queue is implemented as heap? Yeah, basically I tried heap, but it gives TLA error. Okay. So let's I think you understood the solution, right? So yes, we can use heap instead of priority queue, but what happens is the priority queue given by C++ or Java is encouraged, because what happens is they are more optimized, and probably your heap was not that much optimized. That's why it got TLE. And other than that, you can ask, you can post this code on the group, and we will see what are the problems with it, and we will find if your heap had some problem or it was something else. Any other questions? Basically, heap and priority queue are both are the same things, and the priority queue itself is a heap, but it is like, since it is written by C++ library people, they have optimized it more than what your implementation might be. That's the only difference. Otherwise, it should pass. Okay, I think we can move to the second question. The second question was Ravi and Happy strings. So we have two strings, A and B, and we want to convert string A into string B. And what happens is we want to make both strings happy by making them equal. So what happens is we are given initially two strings which may or may not be equal, and their size might also be different. So one of the first things that we need to do is, if two strings have different lengths, then we directly say that these are not possible, because if the lengths are different, we cannot make them equal, because we are only allowed increment kind of operations. So what happens is, if the length is different, we directly say no, and then if the lengths are same, we move ahead. And if the lengths are same, what we need to do is we can select a prefix and increase alphabetical value of all the characters by some same amount x, and we cannot increase prefix if it has a letter z. So what happens is, if you are given a string like xyz, you cannot take the prefix xyz. Or let's say if your string is xyzabc, you cannot take prefix xyz or xyza or xyzab and so on. So which means in the string a, whenever you find the first z, after that every character should match with corresponding character in b. So if first z occurs in a on fifth location, yeah, every character after fifth, and including fifth, by the way. So if a of 5 is equal to z, we need to go to b, and we need to ensure that b of 5 is also z, and all the elements of a after first z should be same as all the elements in b. So what you need to ensure is you need to find the location of first A in Z, first Z in A, and then you need to ensure that all the characters in B are the same. So if you do that, what you will get is you can see, like if that does not match, that means you just can't convert that A into B, which means answer is no. But if that part matches, i.e. the suffix after the first A, after the first Z, what you need to do is you need to iterate through the string, and you need to find yeah. So here what happens is, let's say you take the sample input, right? So it is BACA should be converted to DBDA. So let's do one thing. What we can do is we can take BI minus AI, which will give us the number of increments that we need to do for a particular character. So we can make another integer array which will contain BI minus CI. So first we need to ensure that after, like, we check the first Z thing, right? And now let's say if the location of the first Z was K, so we need to check for A of Z to A of 0 to K minus 1 and B of 0 to K minus 1, that for A, like we have, let's say C of I equal to B of I minus A of I. Now as you all know, like characters are as good as integers in C++ and C, and in Java you can do, in Java and Python you can do ASCII arithmetic to convert them from char to int. So when you do BI minus AI, you will get the difference between the characters. So like if you do character C minus character A, you will get 2, and so on. So using that you can find the difference, and then what you need to do is you need to, like, we can see that only a prefix can be incremented by the same amount. That means what? Like if let's say if K was the first Z, so if K minus 1 character has to be incremented by 1, then all then K minus 2 character will also be incremented by at least 1. So we need to ensure that, and that's the only condition in this question. So if C of let's say C of I equal to B of I minus A of I, now what we need to do is C of I should be less than or equal to C of I minus 1. Because C of I minus 1 will be incremented when C of I, when the prefix from 0 to I is incremented, as well as C of I minus 1 can be incremented when the prefix from 0 to I minus 1 is incremented, which means C of I can be greater than or equal to C of I. And if, sorry, wait, what did I say? C of I minus 1 should be greater than or equal to C of I. If we ensure this condition for all the characters from, if for all the indexes from 0 to K, we get the answer. So like if this condition is satisfied, that C of I minus 1 is greater than or equal to C of I, if the answer is yes, then the answer is yes, otherwise the answer is no. If there is at least one index I for which C of I minus 1 is less than C of I, we have the answer that this string is not possible. So this question was a strings question. Now do we have any questions on this from the audience? Okay, let's move to the next question, which was the last question, and it was set as a hard question, and I think probably we set it as a too tough question. So this question is a modification of the standard question, of a standard question. So the standard question was, you are given a normal chess, and in which you have to find the number of queens which can attack the king. And so let's take that question first. And in normal chess you can just have an 8 by 8 chessboard, unlike n by n here. So let's take the simplified question first. So what happens is, if you can if the queens cannot jump, that means so we need to find the queens which can attack the king. So which means one of the solutions can be, you can go to each of the queen location, and from there you can iterate in all the 8 directions. You can spread in all the 8 directions, and you can see if any of them hit the king. And if they hit the king, you get a counter plus plus, and if they don't, if they hit queen first, then you stop over there. So that's one of the ways, which is suboptimal. And the optimal solution would be you start iterating from the king in all the 8 directions. So what happens is, as we know in chess, a queen can move in one of any of the 8 directions, so like top, down, bottom, left, and in all the 4 cross directions. So we have so we have a cross as well as plus, so it can move in those 8 directions. So what we can do is, a queen can attack a king if it is in either in the same row or same column or same diagonals. So if we have those eight, if we have any one of those 8 conditions, a queen can attack a king. So assuming the jumping thing is not there, assuming it's just normal chess. So what happens is, you can start iterating from a king in all the 8 directions, and you can see uh, which all or how many directions does it have a queen in. So let's say if you go to the king cell, you start iterating in the top direction, you see whether you hit a queen or not, and if you hit a queen, then you do count plus plus. If you don't hit a queen, you don't increment the count, and you do this for the all the 8 directions, so like top, down, bottom, left, and and all the 4 crosses. So another thing that I saw in the code of you all was, like, many of you were writing duplicated code, so that's bad. Please use don't repeat yourself principle. So what happens is, the like try to don't try to write different code for different directions. Just make it generic, so that you can put dx and dy, where dx should go from dx and dy should go like -1 comma -1 -1 comma 0 -1 comma 1 and so on. So using that, you can give the direction, and your same code should work for all directions. So that's one of the things using which you can improve your code. And then yeah, and then let's move on to the difficult part. So in this question, the simple question was just 8-byte chessboard, in which you can start iterating from the king in all the 8 directions. And what will happen is, we will see whether we hit any of the kings or any of the queens or not. And if we do hit a queen, what will happen is, the queen, like, we can do count plus plus, but this solution remains O of n, and memory complexity is O of n square. So and we also have the queen jumping thing. So let's think about what happens when a queen is able to jump. So the question says, a queen can jump at most one queen, which means if we have, let's say in a row, we have k q q q, which means we have one king, and after that we have 3 queens. So if we have that condition, that means um, KQQQ means the first queen, which is just next to the king, will be obviously be able to attack without any jump. The second queen will also be able to attack with one jump, and the third queen will have to jump twice, which means it will not be able to attack. So KQQQ should have an answer of 2. So how do we do this? So one way to do this would be, you go to each queen, you start iterating in all the 8 directions, and see if you hit at least if you hit no queens, or if you hit at most one queen to reach the king, but it is suboptimal, this solution will not work. So how do you optimize it? So again, like the previous one, what you do is, you go to the king and you start iterating in all the 8 directions, but you don't stop when you get the first queen. You stop when you get the second queen. So what happens is, you start iterating from the king in all the 8 directions. So let's say you from the king, you go to the top direction, and you go until you get first queen or you get a second queen. So when you get a second queen, you know that after that you cannot go forward, because after the second queen you cannot meet more queens which can attack the king. So at the second queen you stop, and so that means you start iterating from the king in one of the directions, and you go up to second queen, and then you try to count the number of queens that you meet in all the directions. So that sum will give us the answer. So what happens here is, this solution becomes O of n square, because we need to maintain a board like the one that I've given in the question, and O of n square memory and O of n time, because from starting from the king, you are iterating in all just 8 directions, which makes it O of n. So this solution is good enough to get the 70% score, because n is up to 10 to the power 3, and as I had taught in the tips and tricks video, if your memory complexity is up to 10 to the power 6, so if n is up to 10 to the power 3, n square will be 10 to the power 6, and n square memory complexity thing should pass, which it will. So you will get 70% of the score, because n square memory complexity and O of n time complexity but can you optimize it further? How to optimize it further so that it can pass for n up to 10 to the power 5, which means if n is up to 10 to the power 5, O of n square memory will be 10 to the power 10, which does not work, which means the second half of the constraint tells that we already have optimal time complexity. Now, how do we optimize memory complexity? This is again another topic that I just touched upon in the tips and tricks video, that sometimes memory complexities are also important. So I think many of you might be facing trouble in this like memory complexity thing in the modified chess. So how do we do it? So here what happens is you don't actually need to maintain the chessboard to find the answer. So basically this was an arrays question, and in this what we expected was how to use 2D arrays and how to optimize for the memory complexities thing. So for the original solution was you make a 2D board, and whenever you get a king you put a k on that cell, and then whenever you get a queen you put a q on that cell, and then you do the whole solution. But so that makes like checking, like if you are on a cell I comma j, you can find in O of 1 how, like whether this cell has a queen or not. So that's one of the good things about arrays. But now what we have is we cannot have an array of size n square. So how do we optimize it? So in order to optimize it, what we do is we need to do something complicated so and interesting. So what will happen is we we start whenever we don't make the board at all. So this optimization will be slightly difficult. So we don't make the board at all. We keep the king's coordinates kx and ky, and then for each of the queens we keep getting their x and y. And what we do is we have 8 directions around the king, right? So what we need to check is whether the queen belongs to any of the 8 directions or not. So you iterate on all the 8 directions, and you see whether this queen belongs to any of the 8 directions or not. So let's say what you need to check is if you need to do delta x and delta y. Delta x will be qx minus kx, and delta y will be qy minus ky. So the difference between coordinates of the queen and the king, and you do delta x and delta y, and from delta x and delta y you can find if, let's say, delta x and delta y are -1 -1, that means it is in lower left direction. If it delta x is 0 but delta y is 1, which means it goes upwards. If delta x is 0 and delta y is -1, that means it goes downwards, and so on. So based on, so you find delta x and delta y, and based on their signature, like whether it's positive or negative or so on, first you need to ensure that their absolute values are same. So either one of them can be 0, in which case it is okay, so it is in the same row or same column. But if they are in diagonals, you need to ensure that mod of delta x is equal to mod of delta y, because if that is not the case, then it means it is not properly aligned diagonal x like x. So what we need to do is we need to check whether mod x is equal to mod y, or one of them is 0. And if one of them is 0, then it's okay. And if then if mod x is equal to mod y, that means they are on the diagonals, and what we need to do is we need to divide them by their absolute value, which gives us the directions. So it will be like plus minus 1. So both of them will be like plus minus 1 or 0, which gives, and it cannot be 0 0 because it is given like pieces will not overlap, which means delta x and delta y will be like plus minus 1 comma 0 and plus minus 1 comma 0. So you will get things like 1 comma 0, 1 comma minus 1, 1 comma 1, and so on and so forth. So based on delta x and delta y, you can see which direction the queen is in, and you can make a counter for all the 8 directions. So you can make an array of size 8 which has the count of queens in this direction, and you can do count plus plus when you meet a queen in that direction. So while taking the input for the queens itself, you try to you could try to find the count of queens in that direction, and then you do this whole thing while taking the input. Then you iterate through all the 8 directions, and you iterate on the count array, right? So you see if count of I is 0, that means there is no queen in this direction, which is okay, so you don't increment anything in total. Then if count of I is 1, that means total should be incremented by 1. and if count is greater than or equal to 2, which means there are at least 2 queens in this direction, which means we increment count by 2. So that means like if there are multiple queens, as we had in like KQQQ thing, so if we have a king and then we have a 3 queens in that row, what will happen is it will like only 2 queens will be considered, because the third queen cannot reach to the king. So total increments by only 2. And yeah, I think that's the solution for this. Basically this question is called an 2D array or grid question, and there are many questions based on this, and they can also be called as 2D grid or 2D grid graph questions, which can be found in some HackerRank else and elsewhere. So that's all about it, but it did not involve any advanced concepts other than arrays and just counting in all the like by iterating all the 8 directions. So that was it about this question. So now let's go back to the contest. So overall, what we saw in the contest was that the magical coronavirus question was basically a priority queue question, priority queue or heap. You can solve it using priority queue, and it was basically asked to check your STL knowledge and whether you like know how to use STL properly or not. Then the second question was a string question, which was anyway quite direct and just involved basic operations and like array like manipulation. And the third one was array question, and I think I made it too tough probably. I like only 6 guys tried it and 1 guy solved it. And I think in the contest, in the second strings question, we expected it to be slightly tough, but what happened was Milan and I missed a few edge cases, because of which some wrong solutions were also passing. But I think you can check your, we can see your own code and see if your code is missing any edge cases or not. But yeah, I think a few solutions were missing the edge cases, but they still passed. So that was one mistake from our end, but I think it's okay. Like all of you tried really hard on the first and second question, which is good. And I think in the first question 24 people tried, but only 4 could solve optimally, because what happened was in the first question we had a strict time limit, which means the solutions were timing out for most of the people which were not using priority queue. And in the second question, what was happening was it was a strings question and it had yes no answer. So because of that, we wanted to avoid cheating, because in yes no answers people often cheat. So what we did was we had a binary marking for this question, which means only if all of your test cases pass, yeah, you get a full score, else you get 0. So it is 0 or 100. And that was the binary marking thing. And in modified chess I kept 70% points for the easy subtask and 100% points for the hard subtask. So one thing that we observed that a lot of people signed up for this contest. Let me check some statistics. uh, so I think we had what, uh, we had 66 signups, and out of them 51 people logged in, and out of which only 27 people submitted code, which means like about only half of the people are submitting the code out of 51 who opened the questions, which means probably either you found the questions too tough or you got like confused in the stories. So please let us know what are the problems because of which people are not able to submit questions. So like at least I think in the priority queue question you could have submitted an O of n solution, and in the priority queue you could have submitted an O of n solution and got some points. And in the last modified chess question also, we had first 2 test cases which were using just 8x8 chessboards, so you could have tried them. And in the strings question you had to solve optimally, but I think it was not that hard to think. So please let us know in the comments right now or even later, and on the Facebook group, like what are the things that you are facing, why is the participation and submissions are quite low. And yeah, I think you can ask any other questions. Okay, bye everyone. Thanks for this stream. Bye.